Hello everyone. Today we are going to see the third lecture in trigonometrical leveling in the base of the object inaccessible, and in the single plane method we are going to see the second case. Instrument axis at the station nearer to the object is lower. Let us assume that this object is a tower. Let us keep this point as Q as the top of the tower. We need to find the reduced level of the top of the tower. Let us make a station P. In the station P, let us install a theodolite. P dash is the vertical projection of the point P along the horizontal axis of the telescope. In the theodolite, we have to make a horizontal projection, and along the point Q, we have to make a vertical projection. Let us keep this point as Q dash. Let us keep the horizontal distance between P and Q as D. Let us keep the height of Q dash as H1. In the benchmark, we have to keep a staff. From the station P, we have to see that. And let us keep the staff reading as S1. From the station P, we have to focus the top of the tower, that is the point Q, and we have to take the reading of vertical angle alpha 1. Now we have to make one more station, that is R. In this station, we have to install a theodolite. R dash is the vertical projection of R. In the horizontal axis of telescope in the theodolite, we have to make a horizontal projection. Let us keep this point as Q double dash. Let us keep the height of Q double dash as H2. We need to measure the horizontal distance between the stations R and P, and let us keep the distance as D. From the station R, we have to focus the point Q, and we have to take the reading of vertical angle alpha 2. From the station R, we have to see the staff, which is kept in the benchmark, and let us keep the staff reading as S2. We can see that the station P is nearer to the object. The instrument axis at P is lower than the instrument axis at R. That is why it is known as instrument axis at the station nearer to the object is lower. All the readings related with the station P should have the suffix as 1. That is why here it is alpha 1, here it is H1, and here it is S1. All the readings related with the station R should be suffixed with 2. That is why this angle is alpha 2, this height is H2, and the staff reading is S2. This height should be equal to S2 minus S1. Let us keep that difference as S. Also, this difference should be equal to H1 minus H2. So we can write S is equal to H1 minus H2. Let us take this triangle, and in this triangle, let us apply tan theta formula. We know that tan theta is equal to opposite side by adjacent side. Here the opposite side is H1, the adjacent side is D. So tan alpha 1 will be equal to H1 upon D. We can take D on the other side, so it will come in the numerator. In this way, for H1, we will get D tan alpha 1. Now let us take this triangle. In this triangle, let us apply tan theta formula. Tan alpha 2 will be equal to the opposite side H2 upon the adjacent side D plus D. We can take D plus D on the other side, so it will come in the numerator. In this way, for H2, we will get D plus D into tan alpha 2. Let us subtract H2 by H1. So H1 minus H2 will be equal to this minus this. We know that H1 minus H2 is equal to S. Instead of H1 minus H2, we can apply S. With minus tan alpha 2, we can multiply caps D and the small d, so that we will get these two terms. We can take this term on the other side, so it will come as positive. From these two terms, we can take d outside. We can take this term on the other side. It will come in the denominator. This is the expression to find the distance d. In these two expressions, instead of d, we can apply this so that we will get these two expressions. For these two terms, we can take LCM. We need to multiply this with d so that we will get these two terms. Then we can eliminate these two terms. Finally, for H2, we will get this expression. Using this formula, we can find the horizontal distance d. Using this one, we can find H1, and using this formula, we can find H2. To find the reduced level of the top of the tower, that is the point Q, we can use two methods. Let us see the first one. First, we have to add the reduced level of the benchmark with the staff reading S1 so that we will be in this line. Then to get the top of the tower, we need to add H1. So it will be reduced level of the benchmark plus S1 plus H1. Let us see the second method. First, we need to add the reduced level of the benchmark with the staff reading S2 so that we will be in this line. Then to get the top of the tower, we have to add H2. So it will be reduced level of benchmark plus S2 plus H2. Now let us do a problem. Find the elevation of top of chimney using the following data. The instrument stations are given as A and B. Readings on the benchmarks are given. The angle of elevations are given. The reduced level of the benchmark is given as 420 meter. Station A and B and the top of the chimney are in the same vertical plane. Find the elevation of the top of the chimney. If the distance between A and B was 50 meter, using the data given in the question, we can draw the diagram. Unless it is given in the question, we have to keep the stations in the alphabetical order. The station A should be nearer to the tower. The station B should be after the station A. The staff reading on the benchmark from the station A is 0.865 and from the station B it is 1.22. 1.22 is greater than 0.865. From this we can get the idea. The instrument axis of the station nearer to the object is lower than that of this station. Let us enter the angle of elevation. At A, it is 18 degree 36 minutes and at B, it is 10 degree 12 minutes. The distance between A and B is 50 meter. We know that S will be equal to 1.22 minus 0.865. We will get 0.355 meter. Using this formula, we can find the distance D. Yes, just before we have got 0.355. D is 50. Alpha 1 is 18 degree 36 minutes and alpha 2 is 10 degree 12 minutes. For the distance D, we will get 59.712 meter. We can take this triangle. In this triangle, we can use the tan theta formula. Tan 18 degree 36 minutes will be equal to H1 upon 59.712. For H1, we will get 20.095 meter. We know that H1 minus H2 is equal to 0.355. We know the value of H1, 20.095. We can apply that. In this way, for H2, we will get 19.74 meter. Otherwise, using this formula, we can find H1, and using this formula, we can find H2. Now we are going to find the reduced level of the top of the chimney. We can do that in two ways. Let us see the first one. We have to add the reduced level at the benchmark, which is 420. The staff reading at the station A, which is 0.865, so that we will be in this line. To get the top of the chimney, we have to add this height, which is h1. In this way, we will get 440.96 meter. Let us see the second method. We need to add the reduced level of the benchmark 420 and the staff reading from the station B. So we will be in this line. Then we need to add this height, which is h2. In this way also we are getting the same value 440.96 meter.